Okay, this is the description or explanation how to solve for example 5.1. As I have already mentioned earlier about how to transfer all the meaningful parameter from the question on your graph paper. So after you determine everything from the graph paper, from the question, okay, next to transfer the slope using information to your graph paper. The first step is to draw the, of course, to draw the slope. Yeah, of course we need to draw the slope. Okay, this is how you draw the slope. Of course, this line is based on the measurement that I get from the question. I know that this is 6 meter, and then the information from the question say this is about 9 meter. Okay, the horizontal from centroid to your slope front will be 8 meter, and then from your slope from this 8 meter to the origin, that will be another 5 meter. So this information, I get this first, and of course the most important thing is to draw the slope first. Okay, and then to solve for the questions. Okay, next is to produce the slip failure plane, and that is the semicircle drawing on the piece of paper. So I just read from your workbook how to solve everything using your workbook, step-by-step guideline from your workbook. Okay, the first thing is to determine the value of radius of the circle R. So you have the horizontal line here, which is 5 meter, and then you have vertical line here about 5 meter. And then with that information, you can actually know what will be the length of this radius by using theorem Pythagoras equation. So using theorem Pythagoras, you have R is equal to 5 squared plus 8 squared square root, and that is 9.4 meter. So use this 9.4 meter, use your compass, and then by using your compass, you will draw this slip circle for to show the failure plane of the slope. So we have from line A to line B here. And then next is plot the information given into the graph paper. Okay, meaning that you are plotting the semicircle. But by using R equal to 9.4 meter on the origin point 0. Okay, this is your origin point 0, 0. Draw the circle that connect point A to point B. And then make a dotted line connected from point A to O and from O to B. So you have O to B. Here we have two dotted lines. And these two dotted line and your semicircle, that is a sector. And then using your protractor, you get the value for theta here. So that one is the first information we get before we solve for this problem, which is theta is equal to 108 degree. Okay, next is divide the circle into 5 slices almost with same width, and it is compulsory to make a cut section at every corner. Okay, that statement shows that if you have a change in terms of the geometry, okay, you need to provide one slice from A. This is a flat line to the slope line. We have the change of geometry, so it is the first cut line. And then from slope to your flat at the top of your slope, okay, you have another section to cut, and this will be the second cut. But of course, in the question, it's asked us to make a slice for 5 slice, so you make a 5 slice here. Slice number 1, slice number 2, slice number 3, slice number 4, and then slice number 5. Okay, next from your workbook, it says that you make a table. Make a table is to organize all of our answers, and this is recommended table. You have area, distance, weight, and W times D. Okay, you have slice number, and then you have area, and then you have distance. Weight is A multiplied by unit weight of soil, and then you can get your W. And then next is you need the information of WD, which is column number 4, and then multiply by the distance for each slice. Okay, and then the workbook, the solution in the workbook says that calculate the area for every slice. Okay, for slice number 1, okay, this is slice number 1. Oh, sorry. Okay, this is slice number 1. The shape is almost like triangle. So you must calculate the area using triangle area, and then get the value for that area. Okay, the workbook says that slice number 1 and slice number 5 using area of triangle. Okay, because when we see the shape is almost like triangle, so slice number 1 and slice number 5, okay, the equation is half B times H. Okay, what is B? This is B, and then that will be the H. Okay, so that will be slice number 1, and then slice number 5. You are calculating using the area of triangle and get the value, and you put it inside your table. And from the workbook says that for slice number 2, number 3, and number 4, okay, you need to use a trapezium equation to solve for the shape of this slice. So this is slice number 2. Okay, almost like trapezium. So the equation of trapezium is half over B. This will be the breadth of the trapezium. And then you have 2H, okay, the long side. And then you have H for the shortest side. So that will be the equation for trapezium. So for each of the slice, you need to get the value for its area. So you get the value for area. Okay, it is shown in the table. The value for each area. Okay, for area number 1, of course you need to calculate this one first by using simple mathematic area equation. So area number 1 we get 0.90, area number 2 6.45, Area number 3, 12.6. Area number 4, 15.45. Area number 5 is 8.48. And then number 9, the step in your workbook for number 9, for every slices, calculate the center line. Okay, whatever your shape is triangle, the center line is equal to b over 3 times its width. For trapezium, the center line width is b over 2. Okay, what is the meaning by width? This is the width of your slice. Okay, for your trapezium, of course, this will be the width of the slice. Okay, according to the information in this workbook, so the triangle, let's say we are considering slice number 1 and the width of the slice is about 2 meter. Okay, 1/3 from 2 meter is actually 0.6667. Okay, use that information. Okay, because we want to get the center line for that one. Okay, we need this information. That one is from the last slice number 1. And we need the guide for slice centered line. This is your center. Okay, to determine D for slice number 1, okay, we need to use the measurement from centroid to the line. Okay, that will be D1, referring to your slice number 1. And that D1, because it is from centroid to the left, the value for D1 is taking negative value. From that, okay, you read the measurement, the distance is about 3.8 meter. And then next is the center line for the area of trapezium here. And it says that trapezium is half of the width. So you have 3 meter. Okay, the center line is about 1.5. So you can use this line to guide you. Okay, next, of course, you need to have the information from centroid to this line. To the left, that will be D2 is equal to negative 1.5. Next is the center line for your trapezium here. And then you have from center line to that slice number 3, it is to the right. So D3 is positive value. That one is 1.5. Okay, next we have slice number 4. Again, we have trapezium in terms of its shape. Okay, draw the center line for slice number 4. And then from the centroid to slice number 4 to the right, you get D4 is equal to 4.5. Okay, the last slice will be the slice that looks like triangle. So you need to take 1/3 from its width. And that 1/3, the position is here. Okay, again, you are using from centroid to that point. To the right, that will be your D5 is equal to 7.1. Okay, this is what we call a method of slices. And this is the information we get. Okay, right. Transfer all of this information to your table. Okay, you have the information transfer for D1 negative 3.8, for D2 referring to slice number 2 negative 1.5, D3 slice number 3 positive 1.5, D4 slice number 4 4.5, and D5 you have slice number 5 which is 7.1. So now for the fourth column in the table, you can calculate the weight. Each of the slice you can calculate for the weight. So the formula for weight is area multiplied by unit weight of soil. And the unit weight of soil, you get the information from the question given. The unit weight of soil is equal to 17 kilonewton per meter cube. So I have already calculate the area and then multiple by unit weight. For slice number 1, you get the value 15.3. Okay, you get the value for slice number 2, number 3, number 4, and number 5. Okay, the last column will be W multiplied by D. We have determined D earlier using graphical method. And okay, multiple your W with D, you get all of this total value. Okay, at the end you need to total up what will be the value for WD. So in order to calculate for FOS, again we need to use the equation earlier. We have discussed about this equation, which is Cu r squared theta divided by WD. Okay, the upper part Cu r squared theta is the resisting moment, and the lower part will be the disturbing moment for this slope, and we are calculating by using this equation. Okay, Cu is the information from your question, and then R we have calculated earlier using theorem Pythagoras. That will be 9.4 squared, and theta we get it from protector, you get 0.108 degree, but this one you need to transfer to radian, so multiple by pi over 180 and then divide by WD, which we have calculated using the table. That one is 2304.15. So the end product is the value of FOS, and from this you get the value for 1.59. Okay, this is the factor of safety for example 5.1. Okay, if you have a factor of safety more than 1, okay, this slope you can remark the conclusion for this calculation. The slope is safe because of the value of FOS is more than 1. So that is how you calculate for slope stability, and using this one is we are analyzing using total stress analysis.